Hello, everybody. Hi, Alex.
Hey, Nikola, how's it going?
I'm doing well, and I hope everybody in the audience is doing amazing today. At this session, we'll learn about AI and how to use AI inside of your own Windows application and how .NET helps us do exactly that. Now, one of the best ways to learn about how to use AI inside of your Windows application is to just see what others are doing. What are others building inside of their own Windows applications with AI? One of our what top Windows applications that come with Windows, like Photos and Paint, already use AI models like Stable Diffusion, for example, to generate images, or they use models to remove things from images that are not wanted. Or Teams uses AI everywhere, whether it's to improve the audio that's coming out of your microphone, whether it's to improve the video, whether to add those fun effects. It's really fun stuff. Even Snipping Tool has AI, which allows you to recognize text when you select some text, like an image of a text. You can copy the text. So all these little things that come that can give you some incredible ideas of what to do within your own applications. Same with our third-party applications. Like Be My Eyes is a great example of an application that uses AI to help those with lower eyesight to be able to actually see the world through AI, to understand what they're looking at, to understand, to analyze things, to experience it in a better way. Same thing with apps like CapCut, which allows you to do really fun effects out of your videos when you're actually creating those videos for TikTok or whatever it is. One of my favorite application is actually Power Toys, which is many applications as packed as one. And Advanced Space is one of the latest modules there, uses AI to help you convert things into your clipboard to whatever you want them to do. So I want to show you a quick demo of what that looks like, because I think this is the great example of a Windows application that takes advantage of all the Windows modalities, like the clipboard and all those different things. It lives wherever you are on Windows and injects it with a little bit of that AI magic so you can actually be more productive and do better in those things. So for example, let me just show you how to do this. For example, if you hit Shift Windows V, and you have Power Tools installed, you can download it from the Microsoft Store. You will be able to see the clipboard in there. And so first thing we need to do is to select something, we need to copy something. So I'm just going to go to the browser, and I was looking how to do bubble sort, but I want to do it in C#. I found how to do it in Python. I can either keep searching, or I can just Control C and copy this, and then do Control Shift V and use Advanced Space and say convert to C#. And this will use the OpenAI APIs to actually go and use the language model there and convert it to C#. It looks good. Paste it in. It's done. It's inside of my code. I just converted it immediately on the spot. Or you can do some of the traditional things that you know that you can do with AI. Like, for example, here's a Wikipedia page on a sorting algorithm. I can just select this. Let's say I'm writing a presentation for class or whatever it is. Control Shift V again. Let's say convert to talking. Oops. Someone's calling me. I'm so sorry. Let me just close that. Let's try that one more time. Convert to talking points. There it goes. And then whatever's in the clipboard should be converted to just the talking points for there. I can just paste it. It's just a summary of what that Wikipedia article was. It's a great example of how you can use AI to do the things that are really Windows-like as part of that. So I want to show you how to do this with yourself inside of your own Windows applications. So here is an application that we wrote. It's for note-taking. It's a WinUI 3 WinApp SDK application. Allows you to take notes. We can also support things like attaching attachments. You can see here we have a whole video of the class, and it even transcribed it. We can do things like, hey, I have a syllabus here. I can just add it to my notes, and I can even do things like, hey, I can recognize the text, and I can even select text from there. Look, it's at an angle and everything. Or Alex, for example, send me a voice message on WhatsApp. I'm just gonna include that in here because it's very important that what he said needs to be included as part of my notes, and we automatically transcribe it, and it's in there forever in my notes. So thank you, Alex, for your really beautiful message as part of that. So how are we actually doing this? Well, first, let's start with the easy one. How are we doing OCR here? How are we doing text recognition? What we're doing is using an API as part of the Windows Copilot library that's about to be available as part of the latest experimental release of the WinApp SDK, which uses machine learning models that are part of Windows and makes them available to developers as APIs. So in this case, we're using the text recognizer API. This allows you to, for example, take an image, a bitmap, and get the text in that image. So first things you do, you make it available. What this does, it actually downloads the model on that device if it's not already available. And then once you have the model, you can create an instance of that class and then simply just pass in a bitmap image buffer to that API to get the text. That's it. A few lines of code to actually get text from an image. And it's not just any text. You also can get things like handwritten text. Like in this case, this is handwritten. You get where the text is located. You get the orientation of the text. So you can build some really cool experiences like this inside of your own apps. Now, that's kind of level 100, how to do AI inside of your applications. The second level is using your own models. And for that, we're using, in this case, for recognizing audio and transcribing audio, we're using Whisper. Now, Whisper, if you're not familiar, is an open source model by OpenAI. You can download it on Hugging Face and you can use it within your own applications. In this case here, we're getting it directly from Hugging Face. We actually use Olive, which is a tool for converting models, to convert it from its PyTorch version to the Onyx version. And we're using the Onyx runtime, which is a runtime for running Onyx models inside of our application to run it. We actually have it embedded directly inside of our solution, so we can see it. We have two versions of it. We have tiny and small. Different sizes have different benefits. The smaller ones are faster, but not as accurate. The bigger ones are very accurate, but maybe very slow. Let's look at what this looks like. So if I actually open this in Explorer, and I open this inside of a Neutron, which is a web app for exploring Onyx models, you can see here, this is just a graph. It's just a graph of mathematical operations that's running on top of training data that the model comes with. So that way, every time you pass in audio information, it can go through this graph and get the text. And the reason why I'm showing you this tool is because this is how you actually get what the inputs are for the model. In this case, you can see here, this model takes in many different inputs. One is the audio samples that you pass into the model. It takes in things that's like, hey, how long should the text be? Should we penalize the length of how someone's speaking? And you can look this up on its documentation. And then it also has the output. In this case, is just a single string, which is the text of the spoken word. And then that's it. And then we use the Onyx runtime inference session here to pass in the model path, so the path of the Onyx file. We also do some optimizations here. We enable them to run smoothly on top of our device. And then once we're ready to run this, we get our samples. We convert them to float, because that's what the model requires. And then we create some tensors from that float arrays that we pass on to the model. In this case, you can see here all the different parameters we saw. And then we simply just call a run on that inference session, Windows inputs. And at the end, we just get that value as a string. And now we have the text that the user spoke. And this model also enables things like, hey, give me timestamps that you enable as part of these options. So that way the text that we get is also including the timestamp. So we can do things like, hey, at which point the user said what on that video, on that audio file that we can connect. So now that we know how to get these models and how we can run these models, we can do some really cool stuff, because it opens up the door for using a lot of the thousands of open source models out there on Hugging Face. For example, one of the best features that I really like is, how do we make it easier for users to find things inside of our application, right? I could be searching things. I could be looking for something, but I don't know exactly the text I'm looking for, but I can search for its meaning. So for example, I know the professor was talking about how many parameters a function takes. So I can say number of parameters. Of course, when you're doing things live, things happen like this. So let's try this one more time. I'm going to rerun the application and search it one more time. Number of parameters in a function. Let's see there. So this should find context. You can see here, found that in lecture 2, the professor said functions taken as input 0 or more inputs, which is completely wrong from what I wrote, but completely right in terms of the meaning of what I was searching for. So I can click there. It takes me directly to where the professor at the 12-minute mark was talking about how many functions. So this is a great, powerful experience you can build inside of your applications to make it easy for users to find what they're looking for. The model here we're using is the All Mini LM6 right there. It's all on Hugging Face. We're using the same phonics runtime I already showed you. You can download this model, include a private application, call the code, and now you have this type of experiences running inside of your own applications as well. And one last one I want to show here real quickly is we're also using a language model inside our application. It's completely embedded and running offline called Phi 3. And if you're not familiar with language models, they're these models that can reason over text and they can understand what the text means and they can complete the meaning there. So in this case, I can actually summarize text, right? I can right click and summarize. And the AI here, which is running that language model, it can summarize my notes as part of that content. And it's running completely offline. And none of my data is actually going to the cloud. So it's fast, it's private, and it kind of just hits all the boxes. Or I can do other features like, hey, I want to reason over this text and understand what are some actions I need to take based on these notes. So here I use that language model to tell me what are some actions that the user needs to take based on it found inside of the notes that he wrote there. And for this, we're using Phi 3, which is yet another model that's available on Hugging Face that anybody can use and download. And we're using it in combination with the Onyx Runtime Generative AI API that's pretty straightforward to use. In fact, I want to invite Alex here to show you how we're doing these similar things inside of a WPF applications and how we're using .NET and these libraries to build these incredible experiences. Alex, go ahead.
Hey. All right. So this application that I have is a RAG example, which RAG stands for Retrieval Augmented Generation. And in this case, it's the combination of two separate models. I have an embeddings model, which is exactly the same one that you showed, the all mini L6V2. And that is used to index and get the semantic meaning of every single page of this PDF that I'm giving it. And the second model is Phi 3 Mini, exactly the same one that you just showed us, right? And this process of doing RAG starts by actually indexing the content. So I did this before we started the presentation here because it takes a couple of minutes. But that's because I'm using a very large PDF. It's a 1,400 page PDF. And I index that. I run that same embedding model that Nikola showed on every single page of my PDF. It means that I understand I have a vector that represents the contextual, the semantic meaning of each one of those pages. So whenever I search for something and I ask the LLM, in this case, for something, before I send the prompt to the agent, I'm querying the pages of the PDF that makes more sense, that are more related to my prompt. So in this case, if I ask in .NET, what is a common language runtime? I can click on this button, answer, and it instantly found those pages. It's literally just a vector search comparing in terms of distance every single page that I previously indexed. And then it adds the prompt at the end together with the content of those pages, right? So it starts answering the specific question that I had. This is not something that is completely alien to .NET developers. We had this before, but one of the new things that we have on .NET is now the ability to swap different implementations of this using the abstractions that we have provided by the abstractions layer or the AI abstractions layer from .NET. So we have an interface called iChat client, and within my sample, the only thing that I'm doing is if that toggle is on or off, I'm going to run the local model, or if it's off, I'm going to run the OpenAI model. So I have exactly the same code, and I can switch this flag, and I can run the prompt again. And you can see that now it's much faster. It's actually going to the cloud to get that answer. But that answer came from ChatGPT. It's a completely different answer. It used this exact same content to try to generate the answer. ChatGPT is way smarter than the version that I can run locally. It's much more powerful. You can compare my GPU, my local GPU, with tons of servers running these models on the cloud, right? But you have that ability. You have the ability to say, I have the hardware to run this locally, or I want to offload some cost to the machine. Since you do have some specific hardware that can run these models, then you can offload and choose. But your specific implementation of RAG doesn't have to suffer. It's literally just one abstraction. And if we go to the definitions here, you see that I'm just depending on an iChat client. They're two completely separate implementations. One of them runs online, the other one runs offline. Another thing that I want to show you is specific to tokenizers, right? The Gen AI library provides its own tokenizer meant specifically for Gen AI models. But whenever you're running the embeddings model, you also have to run a tokenizer. It's a different tokenizer, which is the BERT tokenizer. But before the .NET team implemented this in the Microsoft.ml tokenizers library, we had to literally re-implement the wheel and reinvent the wheel. This is literally, it was a beautiful pull request that we merged not long ago, deleting our own implementation of the BERT tokenizer and just using the .NET one. And that's my favorite type of pull request. When you delete code, I'm happy. But this specific implementation of the BERT tokenizer, the only thing that it asks for is the vocabulary file, which is just a dictionary of the specific token and what it means, and then index. And that's pretty much what it does for us, but it does the whole tokenization specific to how it works. And it returns specific data that is used to feed the embeddings model, right? So again, this is just a lot of code that we managed to delete because of these new optimizations, these new libraries provided by the .NET team. But this embedding generator that I have, it also implements an interface. It also has the iEmbedding generator. Just as we had the iChat client, now we have the iEmbedding generator. And it has exactly the same concepts. You can swap implementations between a cloud one or another cloud one or a local one, however you want to do it. But the .NET team provide those implementations to you. It's as simple as swapping implementations. You can even have dependency injection, injecting those different things, those different classes and instances of classes. Without having to change a single line of the rest of your code. Another thing that the .NET team shipped just recently is the Tensors implementations, right? Whenever you're calling these models locally, there usually some kind of pre-processing and some post-processing that has to happen on the inputs. Another code that we had here before using the Tensors implementation was just using floats. And the problem with just using the floats classes on C# is that all that code is running on my CPU. By leveraging the Tensors implementation, I'm not running things on my CPU necessarily. I'm abstracting those things within the Tensor classes, and it is using SIMD operations on ARM and Intel. And depending on specific hardware availability, it's running even things on the GPU. So the performance is extremely more efficient, and we don't have to write all that code again. The Tensors implementations that are provided by the .NET team just solve that for us. So we have read-only tensor spans, we have unsqueeze, broadcast, multiply. There are a lot of different methods provided by that class that help you do that post-processing and pre-processing of your inputs. So that's basically it in terms of new things that .NET did. One other cool demo that I do want to show you, let me just close this up, is a pose detection sample that I have. And in order to do that, let me just quickly open up Task Manager so we can see the processing happening here. Here and here. Oh, here. Okay. No, let me scroll this. Perfect. Now that we have this, let me go to performance. Perfect. So now you can see that this model, this is a pose detection model, also open source, also available on Hugging Face. And the only thing that it's doing is getting every single frame that is being provided by the camera, and it's returning an array with a bunch of different points specific to my face. You can see that there are a few on my ears, my nose, my eyes, shoulders, torso. It has all those points, and I'm rendering on top of it. But as you can see, if I switch to the GPU tab, you can see that the GPU usage is very high. Not only I'm rendering these lines on top of the video, I am also running the AI model for every single frame on the GPU, which is less than ideal. Because in this case, I'm running this sample on the Copilot Plus PC, which means that I have an NPU. Why am I not using the NPU? Well, all I have to do is switch this. And now I'm unloading the model from the GPU. I'm loading it on the NPU. And you can see that the GPU use went all the way down. You can see the graph going all the way down, and the NPU use starts to ramp up. And this is not only more performant. You can see that by the pose detections per second. I think it was around 15, 16 last time. Now it's around 30. So it's faster. It's using less battery. And it's offloading the GPU to do what GPUs are meant to be doing, right? So that's the second demo that I wanted to show you. Quite cool.
That is incredible. And it just shows that by leveraging all this new Copilot Plus PC hardware capabilities, we can do a lot more now, because we can take all these models while still taking advantage of the CPU and GPU and leaving those off to the business logic and have the NPU handle all of that logic for the models, which is incredible. Okay, so I think we're done. I think we're towards the end. Let's just recap the technology that we looked at here from what we talked about. The first thing I showed in my demo was using the Windows Copilot Library APIs. Those allow you to leverage existing models that are part of Windows and make them available to you as APIs as part of the Windows App SDK. And then they will be available starting with the latest experimental release later this year. We'll also include a model called Phi Silica, which is a language model, meaning you can also use that model on top of the Copilot Plus PCs to use the NPU and to do a lot of the cool stuff that we just showed you with using Phi. There's also going to be additional models and features make available through the Windows Copilot library you can use within your own applications, and it's just really easy APIs for you to use. The next thing we use that we didn't really mention that much is DirectML. All of these demos we showed are running on top of DirectML. And if you're not familiar, DirectML is a hardware accelerated DirectX 12 library that abstracts away the actual hardware where your models are running. So that way you as a developer only need to have one model that can target DirectML and let DirectML handle the execution of that model where it's running on the GPU, like an Intel device or AMD or NVIDIA, or it's also running on an NPU device with the Copilot Plus PCs. And it supports really cool features such as 4-bit activation aware quantization, which allows you to shrink down those language models and make them really small, and while still maintaining accuracy and increasing the performance of those as part of that. And then finally is we talked a lot about Onyx and Onyx Runtime. Onyx is just in file format that allows you to represent models, AI models for usage across cross-platform. And the Onyx Runtime is what allows you to run those models efficiently cross-platform across different hardware accelerators. And they use DirectML as one of the execution providers where you can actually run your models. That way you can use Onyx Runtime alongside DirectML and get the best of both. And then Oracle Generate API is the API we use for running those language model. It's yet another layer above Onyx Runtime, which makes it really easy to run these language models like Phi 3, Llama 3, and much more. And then Olive is a great tool for optimizing and converting models. You can take a model like in PyTorch, convert it to Onyx, and you can do quantization. You can even do fine-tuning, and it's a really, really great, powerful tool for you to use. So I want to say thank you for sticking out with us, learning about how to add AI inside of your own Windows applications. And I hope this sets you on a great path for you to add incredible AI functionality inside of your own apps. So thank you.
Thank you very much. Bye-bye.